Thank you for watching Knowledge Academy. Hello everyone. Today we're going to discuss about vectors. Vectors are discussed in physics as well as in math. So today's our focus is more emphasized on physical part of vector. So we are going to talk about vector as well as their concept, their theories, and what is going on in their background. Okay. These are the components we're going to discuss here today. The first thing we're going to talk about what is the physics behind vector. The other thing we're going to talk about vectors and scalars. What are the differences? Then we're going to talk about how can we add vectors graphically or geometrically. And we're going to be talking about vector components. Then the second thing, we're going to jump on the second side. We're going to using the vector to, to add the vector through mathematical. Okay. And here we're going to be talking about more level graphing. Okay, so these are the difference between the two topics. And the last one, we're going to be saying how we can multiply the two vectors. If we have two vectors, we can multiply how many different ones. So let's jump in and start talking about vectors. First thing first, we talk about the physics behind vectors. Okay. So before we start the physics of vectors, we're going to discuss a thing called physical quantity. And what does a physical quantities means? Physical quantities means anything you can touch, feel, and measure. Those are the physical quantities. For example, mass, like you buy some grocery. This is a mass. Can you feel it? Yes. Can you touch it? Yes. This is the physical quantity, mass. Another physical quantity is force. Right? You can feel the force if someone push you. You can feel the force. The third one we're going to be talking about time. Time cannot be feel or touch, but it can be measured. Okay. The unit of time is second. The unit of mass is kilogram, and the unit of force is newton. Okay. Now, physical quantities have two types. Number one is few physical quantity can only be defined or explained by just using basically I would say that physical quantity can be measured by uh, just a number, just like a magnitude. Just like somebody asking you buy 5 pounds of banana, they does not have to tell you anything else, like 5 pounds banana, okay, or 5 kilograms banana. But if you're asking about force, if I say 10 Newton force, and this is not enough, I have to give you the magnitude, which is magnitude, and plus I need to tell you direction. Like I'm asking you apply 10 Newton on a force on this particular object, maybe a chair. I want to ask you to push the chair, so I should tell you the direction. Okay. So direction and magnitude are two things. The third one is time. Time is also a just need in number. So you can say, I'm going to finish the exam in 3 hours. Right? Is enough. Now, physical quantity have two types. One is scalar, one is vector. So scalars are only need magnitude, just like time and mass here. I mean, I can tell you how much. That's a magnitude means how much. Vector means I need magnitude plus I need direction. Okay. So if I want to do in short, what is mass? Mass is scalar, S, and what is force? Force is vector. What is time? Times. Okay, so these are the scalar and vector differences. Now, before moving forward, I can add two vectors together, right? Or I can add two scalars together. But the thing is that we have to keep in mind, if I give you the vectors, let's suppose I say you bought 3 pounds of banana and you bought 5 pounds of apples. So you can add them together, the answer will be 8 pounds. Okay, simple, because they are scalar, both are scalar. But if I'm asking you, you have a force which is vector. Let's suppose you have a force equals to 10 into, and you want to multiply force equals to 17 Newton. If I want to multiply the two, then I have implications. I just need the product, but I just need the product as well as the fraction. So really what it does that mean is you want to multiply the two number, or with the two forces, one force is here, one force is there, you want to be taking care of the fraction as well. So multiplying the vector is not as simple as scalar. Okay? So multiplying the vector would be a little bit difficult, and or we're going to be talking about that, how we can multiply the vector. That's what we do here. So let's jumping into the talk about how we can add the vectors geometrically or graphically. That's the key here. I'm going to add the vector graphically, and I would say that I do it. Now, how can we add vector graphically? So in order to add vector graphically, first of all, I need to know how can I draw the vectors. In order to draw the vectors, I need to draw a arrow. It means a vector in its direction. So if I make a vector like this, I have to make a little tail or arrow on the top of that. Means this A is a vector, and A starts from here to, and A equals to, let's suppose, 10 to 5, right? I don't have to mention this A value, so at this point, I'm just going to be very, it's just called A vector. But A, they're basically representing, it's a vector. It could be any. Now I have another vector, B vector. And if I'm asking, you can add A and B together. And B also, we can have a little arrow, it means B is also a vector. So if I want to add A plus B, and it should be equal to another vector. If you add two vectors, it's going to be add another vector. Now, geometrically or graphically, how can I add vectors is what I'm going to do. I'm going to be just taking called head to tail. Head to tail. What does that mean? It means the head of the last vector should be joining the tail of the head of the first vector should be joining the tail of the last vector. So how can I draw? I'm going to just take this A and then draw as is. And then I'm going to take this B and then place the B over here in such a way that it's going to be, so this is B, this is A. And if I'm adding together with my resultant, like C vector, should be starting from the tail and ending from the last head. Last head means the head of it. So if I connect them together, and the yellow one is called C. This is graphic. Yep. So let's take a look at some other example. I can do it. Okay. Another example is that you have a vector like this, A, and then you have a vector like this, B, and you have a vector like this, C. If I'm asking you adding A plus B plus C, you can do the adding. Addition will be like this, and it should be a new vector. So how can I do? I'm going to draw A, and I'm going to draw B. A, B. I want to put the C here and stop. Okay. Now, according to the rule, I just told you what you're going to do. You're going to be just going here and making a vector starting from here and ending. So I'm going to draw a vector. Okay. That is a graphical method. And after this graphical method, you know, it's pretty quite simple if you want to add a scalar, right? In order to add the scalar, it will be much easier. Let's suppose if somebody someone is asking me adding a scalar. So if I'm gonna ask you adding scalar, let's suppose you buy root one equals to 5 pounds. You bought roots 2 equal to 7 pounds. So total, how much is you bought? So you're gonna say, you know what, 1 plus 2, and then we're adding together is going to be 5 plus 7 is equal to 12. And that is your answer. And we also learning one more thing is that if we adding two vectors, right, uh, it's really not much different if we adding the vector in the different directions. For example, if I want to add two vectors together, and let's suppose the vectors orders are different. To give you example, you understand it better. So I'm going to say is A, vector A is like this, and vector B is. So if I'm asking you to add those two vectors, A and B, we're going to say A and B, so you draw the A, you draw the B, A, and you're going to be drawing the vector as C. Okay. Now, if I'm asking you to draw A and B, you say this is A plus this guy is A plus B. If I'm asking you adding B plus A, so it should be same, right? B plus A should be same than A plus B. So adding together and see what's going to happen. B means going to be adding like this, that is my B, and then A I'm going to be taking and then adding B to it. So B first, A second. Okay, and then if I'm going to be adding this yellow vector, I'm going to be adding this. It's going to be also like C. So if you pay attention, this C vector, like this C vector, and this C vector are same, but I can say equal, right? So that's the beauty. You can just add two vectors like this, and then you can add two vectors like this. Their end product is this guy, the center one should be same, right? So you can see here this C and then this C is basically same. So these are the one we add vectors. Let's talk about the component of the vector. Okay. Now the component of a vector, which is this vector, and component of vector is very straightforward. What does that mean? It means I have one vector like this, A along x-axis, right? A along x-axis. And I have another vector B along y-axis. I have no problem with A and B. The problem is that sometimes we have a vector which is an angle. I have a vector which is an angle. For example, I have this x-axis, y-axis reference frame. I have an x, this is y, this is minus x. Let's suppose if I have a vector, here, I'll draw the vector here. Now this vector is not along x-axis and not along y-axis, so I need to split the vector. So I'm going to take this vector, I can make it A is called just for the sake of simplicity quality. This vector need to be split into two components. And what does that mean? It means A has to be split. So I'm going to take this vector, go to the head, which is corner, and drop one perpendicular. I'm going to also drop a perpendicular here. And what I'm going to do, I'm going to draw two vectors. One this component, the green one, another component on the other side of the green. So really the white color vector from A has to be split into two called A X and A Y. So really I'm going to be writing here A X and A Y are rectangular components of vector A. Okay. How do we calculate vector components of vector A? I'm going to say there's a formula is given in the book. Ax equals to A cos theta. This theta is basically an angle from here to A cos and AY equals to A sine A cos theta, A sine theta. If I gave you the component, you can find the vector by using this formula. If I give you component, let's suppose AX and AYs are given, the components are given. You're going to be calling them. And how are you going to calculate the A? So A equals to square root of AX squared plus B. Same thing if I gave you component, if I am asking you to calculate the theta equals to tan inverse A Y X. Okay. Now let's move into the component of a vector component or adding them a vector component. But before moving forward, just keep in mind every time you write a vector AX and AY, you just write in AX and AY. So you're going to write like this: A equal to AX AY. Since this is the X component, you're going to be writing the unit vector I, another vector J. So this I and J called unit vector. Unit unit vector means a vector having a magnitude equals to 1. Now, this is a vector. You're going to write like this. So for example, if I want to write a vector, right? If I want to write a vector, maybe I can for example here, I'm going to give you a vector R. R have two components. This vector called Rx, this vector called Ry. Since R is a vector, I give you Rx equals to 3, Ry equals to 5. So how are you going to write vector? Vector R should be like this. Rx plus Ry, two components, and you can also write like this. Let's say what? I'm going to write 3, 5. You're also writing 3i, 5j. Okay. If you want to write like this with comma is fine. Sometimes you're just writing the plus sign. If it's a vector that is given in a vector form, not in a coordinate form, so you can write like this: R equals to. If I'm asking you, see here, I just gave you a two component of vectors like this and this. By using this formula, you can actually find the R. So what you're going to do, you keep the R here, AX is replaced by 3, AY replaced by 5. You take the 3 squared plus 5 squared, and then solve it, you're gonna find the A. Same thing if I'm asking you the angle, like this angle. You can substitute the value here and here, both Rx and Ry. So this is Ry, and this is Rx. Just a 5 and 3, not I and J. All right. So if I gave you two component of a vector, you can simply just add them together, and then it's going to be straightforward. And how can I add them two vectors? I give you examples. It's very simple. We are adding vector components. Adding vector components. Adding vector components. In order to add vector components, I have to take two vectors. So two vectors given, let's suppose I'm just writing in a general form, not writing in numbers. I'm just writing in general form. So you can be writing a, x, y, and then j, a, y, j. And then vector b, I have vector a. I'm going to make these little arrows, meaning both are vector. I'm going to say bxi plus by. So if I get earlier, I use the head to tail rule, something look like this, and then adding the vector. Okay, this time I'm not using this. I'm going to be using mathematical way to adding vectors. So if I got a plus b, I'm not going to use the graphical method, the one I used here. I'm going to be using a mathematical method to get adding the vectors, which is this one. And what I'm going to do, I'm going to call it ax plus bx, both adding together, and then plus ay plus by j. And if you're adding together, you're going to get another vector. You're going to get a vector here. Maybe you can call it some numbers, and you're going to get this number with I sign, and then plus some number with j sign. So you have some number written here, some number written here. That's you can solve this vector. Now we're going to be talking about how do we multiply the two vectors. Okay. Multiplication of vector is representing by. Now we're going to be talking about how we're going to be adding two vectors. And in order to add the two, multiplying the vectors, so I'm going to say multiplication. Multiplication of vector have two methods. The first one is when vectors only number need to be multiplied. Okay, just like 5 Newton force and 6 Newton force. If I want to multiply the two, the answer would be 30 Newton. I can multiply the two. This is this multiplication called dot. And if I have this 5 Newton is this direction, this 6 Newton is, maybe up towards up. If I want to multiply the two, I cannot simply multiply the two. 5 times 6, answer is 30. The issue is that I cannot do that. I have to do a different methodology because what I'm going to do with the direction. So I need to multiply like this. So first method is only 5 multiplied by 6 and call it dot product. When I multiply the vector with direction, with the other vector with direction, I call this another thing, and that's called it cross product. Okay, so I have a dot product, I have a cross product. So let's do one by one. What are those? We're talking with a dot product, right? Dot product. Dot product actually measuring how much two vectors are in the same direction, or how much two vectors are aligned towards the same way or same direction in the same way. Okay. So in order to do that, so when you're multiplying the two vectors in a dot product, the answer is also a scalar. Remember, because we not care about the direction, we're just multiplying the two vectors magnitude. So how can I write two vectors multiplication? If I have two vectors, I can write a dot b. Since it's a dot product, I can say a dot b, and answer would be a b cosine theta. Just writing better. And that's the formula for dot product. And we're writing a b cosine theta. Okay. And what is a theta? Theta means theta is angle. Theta is angle between A and F. You have to remember this angle between A and B. And this is the magnitude if you have a magnitude is given. But if two vectors are given A and B in a vector form, how you can do that? If this is a magnitude form, the other formula is that if it's A dot B, you want to do the dot product, and both A and B are given in a vector form. Let's suppose A is written like this. A has the component x, y, z. So you're going to call A x I plus A y j plus A z k. Right? Vector have three components. We learned about that before. And I'm going to say dot here. Then B x I plus B y j plus B z k. Okay. So you're going to multiply that, and if I multiply, so really what's happened is I multiply I, right? I, and both I in a unit vector in the same direction. So when the two vectors are in the same direction, I dot I, cosine 0, this is cosine 0 will be 1 and A times B. So really what's happened, this guy multiplied by this. So basically what I'm saying, in short, this whole term multiplying this. So when AX multiplied by BX, you're going to write like this. And I multiply with this I, so I dot I, and I both in the same direction, so angle will be 0. So you're going to take cosine 0, and cosine 0 equals to 1. So really this I dot I will be gone. So if I'm going to write in this one, it's going to be look like this. If I multiply this with this AX BY, sorry, BX plus AY BY plus AZ plus AZ times BZ. And this is my answer. Okay, let's take a look on cross product and see how the cross product look like a little different. And when the cross product, we have to do a different formula. So let's talk about the cross product. When we talk about the cross product, our answer should be answer is a vector. Remember when you multiply two vectors and we want to know that we want to take consideration of their direction. So both two vectors multiply, the answer would be vector as well. And the formula of this is going to be C A B sine theta. Over there was cosine theta. Here we have sine theta. And what is theta? Theta is nothing but theta is angle between A and this one. Now, since this is a vector, if I multiply them, you're not going to get the vector. So I have to define here a unit vector. And my answer would be this unit vector should be 90 degree to A and 90 degree to B. So how does it work? If you have two vectors, A cross, this you're going to be writing like this, A cross B, and maybe you can write A cross or A cross product of B. So if you have A cross B and you want to take the vector product or cross product, you're taking the right hand rule. So it means your right hand, you have a thumb and you have an index finger, right? And you have a middle finger. So you just do like this, right? So you just open three fingers. So every finger making like 90 degree to another finger, right? And you're gonna be doing what? You have A and B, so you're gonna put A here, slide A, B in the other direction, and then the resultant, which is after you multiplying the two, the resultant may be called C. So when you multiply A across B, the answer may be C. So C is, so you can see here, C is 90 degree to A, C is 90 degree to B. Okay. Let's take a look at another problem. Here, what are x component and y component of a vector in xy plane if the direction is 250 degrees counterclockwise from the positive direction to the x component and its magnitude is 7.3. So really what it's saying, if you draw this, okay, and if I'm going to draw the vector is 250 degrees or 180 and then 250 somewhere here, roughly somewhere here. Okay, we're going to draw this vector. So really this angle is given 250 degrees. This vector size is 7.3 meter. Okay, maybe I can call this vector A. So I need to calculate x component, y component, right? So what you're going to do, you're going to just take this dot and then drop here. That is my y component. And if I'm going to drop on x, that is my x. So really I want to calculate a different color, maybe use. So I'm going to use this green color. So I need to calculate what is the size of these green vectors. I'm going to call this is AY, and I'm going to call this one drop on x. Okay. A few minutes ago we learning about AX and AY. So AX equals to A cosine theta and AY equals to A sine theta. Okay. I'm going to substitute the value AX equals to 7.3 meter and then cosine 250 and then AY equals 7.3, sorry, and then sine 2. Now, if I add them, multiply them and get the answer, it's going to be minus 2.5, and it's telling me this minus towards here. So here towards this direction, here x-axis is minus, so my answer, my AX should be negative. Okay? Same thing, my AY should also be negative because downward, like this is a positive y, this is positive x. But unfortunately, in my question, both AX and AY in the negative x and y direction, so my answer both should be negative. And then AY should be equal to minus 6.9. These are the two answers I have here. Now, if I want to calculate just, let's suppose you give me the vector components, I can also write A equals to AX plus A, but I also need to add this A with A, and then J with AY component. I can write like this, or I can write like this, minus 2.5 I minus 6. That is my vector. If I want to calculate the angle by myself, let's suppose I can just verify. So I can say theta equals to tan inverse, and I'm going to apply AY over AX. Both values are given here, so I can just, so you know, if I can put it here, and I'm going to say minus 2.5, sorry, minus 6.9, because AY in the numerator, minus 6.9 and minus 2.5. So if you solve that, theta should becomes around 250 degrees. This is what is given up. Let's take a look at another problem. In this problem, we're going to be talking about a displacement vector of xy plane is 15 meter long and directed at angle of 30 degree. In the figure 6.26, determine the x component and y component. So it is given like this. The figure 6.26. 3.26, and this 30 degrees angle, and then the vector is this, and I can call this called d vector. Okay, d vector is 15 meter long displacement. I want to calculate the x and y components. So what I'm going to do, I'm going to be just dropping, go to the tip or head, and drop here. I'm going to make these arrows yellow component. I'm going to call this is dx, maybe it's a d. Now we calculate dx and dy. And this is d cosine theta, dy equals to d sine theta. D is given 15 cosine 30. Here same thing is given 15 sine 30. If I take further, it's going to be 13 meter, and this one is going to be 7.5. That is my answer. That is my answer. If I want to draw this thing, this dy equals to 7.5 meter, and sorry, this one is 7.5 meter, and this one should be 30 meter. Let me just make the correction. It's not look like the reverse dx, and I'm going to say this. Okay. If we like to finding the magnitude, which is already given, you can double check, you can substitute in the formula, and you can answer. Let's take a look at another problem. In this problem, we need to convert angle into degrees. So angles have two units. Angles can be measured in degrees, which is this we call this, for example, 30 degrees, 40 degrees. Angles can also be calculated with radians. And radians does not have any unit, but radian called pi radian. Just like land can be measured in millimeter and kilometers, we can convert them. The conversion between the two is 180 degrees equals to pi. That is it. So I want to convert a few of them. Maybe let's just start with the first one, like this one, A. So can we convert this 20 degree into radians? Let's try. 20 degrees need to be converted into radians. Okay, and we know pi radians equals to 180 degrees. So I'm going to take this guy who says 20 radians. If I want to do it, I'm going to be just multiply with pi over 180, right? Pi over 180 is what? Let's say just pi over 180. And if you multiply, the answer is going to be 0.9 degrees. So really 20 degrees equals to 0.3. Another part of this one, I'm going to be converting the radians into degrees. So let's try that one. Zero 0.33 radians equals to 0.3 multiplied by 180 over 5. Just flip over, and the answer will be 18.5 degrees. Okay. All right. In this problem, is a little bit in detail. So in this problem, in a unit vector notation, what is the sum of a plus b if a equals to this and b equals to this? And what is the magnitude of the fraction of a plus b? So what you're going to do, we know that if I have a equals to ax plus bx by, and you have I, there is a j, and you have another vector b equals to bxi plus byj. How can I calculate a plus b? I'm going to be adding these two, so it's going to be a plus ax plus bx common I plus ay plus by. Okay. So what you're going to do, everything is given in this problem. I can do what? I can just substitute the value. So I'm going to be substituting the value is going to be 4 minus 30. This 4, right? So writing this. This one is this. This one is this. Ay, sorry, ay is this. Okay. And by is this. So I'm going to substitute the value. Is going to be 4 plus minus 30 I plus 3 plus 7 j. The answer is minus 9 I plus 10 j. That is my A plus. Okay. I also have to calculate in this problem what is the magnitude of the two. So A plus B magnitude, so I'm going to A plus B, and I'm going to make this magnitude, and it says 9 minus 9, so square plus 10 square. So answer is 81 and 100, right? 81 plus 100, and then you solve it and I get the answer. That's it. Now I also need to do, so this is A, that is B part, C part same fraction, so theta I know tan inverse AY, so maybe I can call this C vector, so really it's going to be the component of Y component over X component, so really Y component is this, and X component is this. So let's substitute the value. So I'm going to be writing like this, theta equals to tangent inverse tan the minus 48 degrees, you can say is minus 48 degrees, or you can say that 132 degrees. How come it comes up? I'm going to take 180 degrees minus 48, which is going to be answer 132. So really, what does that mean? If I have a vector like this, I'm going to draw maybe here. So you can measure this angle, which is minus, that's why I came with minus sign. Usually, you're supposed to be measured from here. So if you're not measuring, if you're getting an answer in minus, it means this minus same. You go to minus negative, minus x-axis and measure the angle, which is not really making a difference. You can measure from here or you can measure from here. But standard is you're supposed to be measured from positive x-axis. So what you do, you're just taking 180 degrees and minus 48, and your answer will be 32 degrees. So this 32 degrees, so 132 degrees is your answer. Let's take a look at another problem. Okay, here's a dot product. We already talked about that. Dot product can be multiplied. A dot B equals to A B cos theta. But here we don't have the A in AB form. We have the AX I plus B A yj, and then you have dot bxi plus by. So this thing to multiply to this, and this thing multiply to this. So you're going to be writing a dot b equals to same thing ax bx plus ay ey. Okay, so I'm going to substitute the value here. So it's going to be minus 1.1 times 1 plus 2.0 times minus 1. So if I multiply, the answer will be 1.1 plus with minus, so I'm going to write minus 2.0 here together is going to be minus 0. Minus some, okay, and at a dot equals. Let's take a look at another problem. We have a cross product of the two vectors. Cross product is a little bit different. If the vector is given in the magnitude form, like a cross b, we just talked about that, how you can multiply. Its formula is that a b sine theta with the unit vector. But our vectors are not given in the magnitude form, they're given in the vector form, or unit vector. So what I'm going to do, I'm going to call a cross b equals to, writing like this, I, j, and I'm writing a vector. Let's suppose my vector is given a equals to the vector given in our question is given in this form, a equals to axi plus ayj, b equals to bxi plus. So what I'm going to do, I'm going to be just taking I, j, k component. So I'm going to take this, and the k component I'm writing here. But since in this problem we does not have really k is given, so I'm going to keep it to ij and ignore this k. Okay. So I'm going to be writing this ax and ay component. So ax and ay here is, this is my ax, guys. That's my ax. That is my ax, my ay, my ex. So I'm going to be writing these vectors here. Ax, ay, then bx, and do the determinant. So before I do anything, I'm going to just substitute the value. So I'm with I, j, and writing my vectors. So you'll 2.2 and 3.4 and 4.4, 2.0. So what I'm going to do, I'm going to multiply these two minus these two. So answer will be here 2.2 times 2.4, and both should be inside I, right? And this one is 4.43. I'm gonna get this one. So you multiply that, and probably whatever you solve it, that's gonna be your answer. But you pay attention, this is gonna be a vector. Thank you for watching Knowledge Academy. Please subscribe my channel.